2. Day 5. Okay. Now, we're going to use all that stuff we did to describe the effect that's going to happen. The effect is what happens to your thing. Does it get bigger or smaller? And how much bigger? Did you times it by 2? Did you times it by 10? Did you times it by 2/3 and make it smaller? Did you times it by 1/1,000,000th and make it really, really tiny? So that's what we're talking about, is what did I multiply by? Okay? Now, I want you to remember, okay, area is 2-dimensional, lengths are 1-dimensional. So it says the base and height of an isosceles triangle. Okay, and it's got a base of 12 and a height of 6. So that's like extra added information. But the base and height are both tripled. Okay, what does it mean to triple something? What math thing are you doing when you triple? That means times by 3. Okay? Now I'm going to show you the long way to find this and then my world's favorite shortcut. Okay? The long way to do this is to say what was done to my base? It was times by 3. What was done to my height? It was times by 3. And so for my perimeter, okay, what's my perimeter ratio going to be? Remember, it's going to be new over old. So what's my new perimeter going to be if I tripled my base? What's my base going to be? 36. Oh. And my height is?
18.
How much? 18. Oh. In an isosceles triangle, if the base is 36 and the height is 18, oh, is this going to get ugly? Yeah, you're going to have to find this slant guy in order to figure out the perimeter.
Oh, no.
Do you guys want to do that?
No.
Probably not. So just so you know, okay, crazy things end up happening. This ends up, what's your old perimeter? Can you figure, oh, I don't know my old perimeter either. So, because I don't know what these sides are, do I?
No, you can find out.
Okay, and so this is going to be a hot mess, and that's going to take forever. So to avoid doing all that, here's what I do. I say, well, what was my side ratio if I tripled stuff? Well, my new guy is 3 times bigger than my old guy of 1. Remember doing that? Okay. My side, because I tripled, so for the new guy it's 3 times bigger. My old guy will stay the same, so my old guy is 1. Okay, so that's the ratio of my sides. How do I get the ratio of the perimeters? It's the same. So there's the ratio of your perimeters. Did I even have to find the perimeters to do that? No. Okay. For the area ratio, okay. Oh, what did I do to both of these things? I tripled them. And so, okay, well, to get my area ratio then, I have a 3-to-1 for my perimeter, and what do I do to my perimeter ratio to get my area ratio? Square it, which gives me 9 over 1. Could I have found my area?
Sure.
Sure, remember area of a triangle is what, 1/2 base times height?
Yep.
So what would the area of the old guy be? It'd be 1/2 12 times 6, which would be what, 36? And the area of the new guy would be 1/2 36 by 18. What is 18 times 18? You were supposed to memorize that one. Is that one 324? So with the calculator, 18 to 324. Oh, let's set up the ratio. New over old. Does that simplify to 9/1? Someone do 324 divided by 36. Do you get 9?
Yeah.
Okay, so see, it worked. So could you find your area ratio using the actual areas?
Yes.
That's the long way. The short way is to use your side ratio and say, oh, I know it gets squared. Questions? All right. The base and height of this triangle are both doubled. Okay, so how am I going to get my perimeter ratio?
10 plus 10. Well, 10 times 3. Because it's
Well, oh, you're making it harder than it is.
oh.
What's my side ratio?
2/1.
Ah, it says everything is doubled. What do you do when you double stuff? You times by 2. So you doubled it, you timesed it by 2. So my side ratio, my new one, if my old one was 1, what's my new guy?
2.
2. So what's my perimeter ratio?
2/1.
It's 2/1. Okay. What's my area ratio going to be? It's going to be 2/1 squared. Is that 4/2 or 4/1?
4/1.
It's 4/1. Now, we have not answered the question on either one of these yet. It says, describe the effect. Okay? The effect here, if I do a perimeter ratio of 3/1, that means my perimeter is 3 times bigger. That's your effect. If my area ratio is 9/1, what is the effect on my area? The effect is
9 times.
9 times bigger. Yes?
Do you need to do all that work?
No, you can do the short work. Here, okay, describe the effect of change on the perimeter and the area. So what is the effect on my perimeter here? 2 times bigger. That's the effect on my perimeter. What's the effect on my area here? 4 times bigger. And you can, I'm cool with you even putting 4x. I don't know about teachers in other classes, but I will do 4x for 4 times. Okay? How you feeling so far? Oh, we lost one. Oh, no, we're good. He's not completely dead.
He's mostly
Yes.
dead.
They put that together, like the perimeter is 2 times bigger than the area is 4 times.
Yeah, that's it. Okay, now I'm going to do something different. Here, I changed both dimensions the same amount, didn't I? So the base and the height both tripled. Here, the base and height both doubled. What if I don't change them the same amount? Will it be similar anymore? No, because in order to be similar, everything has to be proportional. If I don't change them by the same amount, will they have the same fractions anymore? No. Okay? So for this set, where I don't change everything the same amount, they won't be similar anymore. But we can do things the same kind of way. Okay? So here, it says the height of the triangle is doubled. What's the change on the area? How does the area change when you double just the height on this guy? Okay? Well, I'm going to show you the long way. I'm going to show you the short way. If I just double the height, what will my triangle look like?
24.
How tall will it be?
24.
It will be 24. how long will it be? It's still 21 meters. Okay? So what would be the area of this top guy, my old guy? Well, remember, it's 1/2 base times height.
252.
So it's going to end up being, but it's 1/2 base times height. So it's going to be 126 meters squared. So that's my old area. On this guy, my area is going to be 1/2 24 times 21. So what does this area end up being?
252.
252 meters squared. Oh, so new over old is, what's my ratio then? What's my area ratio? It's 252 over 126, which is, simplified, 2 over 1. So what effect do I get if my ratio is 2 to 1? The area is multiplied by 2, which you could say is doubled, but I want you to tell me what it's multiplied by. So it's 2 times bigger. Normally, wouldn't area be squared 4 times bigger? But I didn't change both dimensions, and so it only got twice as big.
That's very
Crazy, right? All right, the base of the parallelogram is multiplied by 2. Oh, wait, I didn't show you the shortcut way to do this one. Do you want to see the shortcut?
sure.
Okay, the shortcut. How many dimensions are in area?
2.
Area is 2 dimensions, right? Length and width. Or height and base. What did I do to the height? Doubled it, so I times by 2. What did I do to the length? Nothing, which means I timesed it by 1. Multiply those together. What's 2 times 1?
2.
Oh, what was my effect?
2.
I multiplied by 2. Nice little shortcut, huh?
We got straight triangles.
It works for any shape.
So just one side is what
If it's just one side gets changed, it's just going to change one dimension, and that's what it'll stay. So here, the base of my parallelogram is multiplied by 2/3. Okay, and I want to know how the area will change. How many dimensions are in area? 2 of them. What am I doing to the base dimension? I'm timesing by 2/3. What am I doing to my height dimension? Did it tell me? Nothing. So what do I multiply by to change nothing? 1. So guess what the effect is going to be? It's whatever 2/3 times 1 is, which is 2/3. So your area should be multiplied by 2/3. By the way, is that bigger or smaller? That's a shrink. Okay. Let's check it real quick. Okay. For my old guy, what's the area of this? Oh, how do you do area of a parallelogram? Candy? Area of a parallelogram. What do you think?
Do you cut off the 2 triangles?
That's too complicated. Yeah.
Actually, no.
Yeah. It's just base times height. It's just a rectangle that's been pushed slanty. So it's just base times height. So it's going to be 9 times 24. And so that is going to be my area. So the area is going to be 216. And what's that, square inches? Okay. If I did the new guy, okay, it says to multiply the base times 2/3. So what would be my base on my new guy if I did 2/3 of 24? That's going to be 16 inches. But what's my height still? 9 inches. So my new area is going to be 9 times 16, which is only 144 square inches. So when I do my area ratio, what's my new one? Oh, that was, yes. You put a square on that. Go get it. Thanks. So what's my area ratio going to be? New over old? 144 over 216. And the units cancel. Guess what this simplifies to? 2/3. So which do you prefer to doing? All the math or the shortcut?
Shortcut.
Most people like the shortcut. Okay? Describe the effective change on area whose base is doubled. Oh, now look what happens. The height is 1/3. Now I want to change the area. How many dimensions are in area? 2 of them. What am I doing to the first dimension? I am doubling it. That means to do what? Times by 2. The height dimension is 1/3 as much. So what am I going to put here? 1/3. So my area ratio is going to be how much?
2/3.
It's going to be, remember, 2 is 2/1, and then you multiply straight across the top and straight across the bottom. It's going to be 2/3. Oh, so what's my effect? What happens when I go to my new one?
2/3.
It's multiplied by 2/3. That's the effect. If you double the base and 1/3 the height, you end up multiplying the area by 2/3. That's it. Yes? To check the answer, that would mean, do you want me to check the answer? Do you want me to find this area in my new area and set it up for you? Only if I tell you to on a quiz or test. Oh wait, we already took our quiz. So only if I tell you to on the test. Okay? Yes?
So why did they describe the effects for each change of parameter or circumference?
Which one are you on?
Alright, I was just looking at the top.
This top stuff is for these two guys. But then we have, this one just says change of area.
We didn't do circles.
Oh, you saw, how do circles work? Oh, guys, shh. So how about circles? If I wanted to do a circle, let's say I've got a circle. How do you do perimeter area of a circle?
Pi times the diameter.
Perimeter is pi times diameter, which is also 2 pi r, if you want to break it up that way. What is area of a circle?
Pi r squared.
It's pi r squared, but wait a minute, pi r round. How can pi r square and also pi r round? I'm confused. I guess we need to make all pies square now. Sorry, all your pizzas have to be square now.
No,
You said pi r squared. So we have to make all pizzas and all pies be square now.
but that's just
No, but it says pi r squared, so pies cannot be round. Sorry, pies are square, not round.
life sucks.
And pizza is just a pizza pie.
Life sucks.
I know. Okay, but it still goes back to the same thing. How many dimensions are in perimeter, or as you call it for circles, circumference? How many dimensions are in circumference?
1.
Just one dimension. So if you change the radius by a scale factor, how is the circumference going to change? By the same scale factor, because it's just a perimeter. But for area, how many dimensions is area? 2 of them. But the trick here is, what things are we multiplying to do the area for a circle?
Pi.
It's radius times radius. The pi is just a number. But it's the radius. So instead of base times height, we're doing radius times radius. The radius is acting like both your base and your height. So if I change the radius here, let's pretend I doubled. If I double the radius, and I want to do the area ratio, what would happen to my first dimension if I double it? It'd be doubled. But what would happen to the up and down radius? It'd also be doubled. And so the area would be 2 times 2, which is 4. Oh, so it just squares, just like we said back in the beginning. Because in a circle, if you change the dimension one way, you change it every way. All circles have to be similar. And since circles are similar, you have to follow this rule, where it just squares. Okay? All right. You are now good to attempt the homework and see how well you can do.